Afternoon, everyone. Thanks for sticking around. It's a real privilege and pleasure to be here in Mines and Wines. I've been trying to get here for many years, and it's great to finally make it. Unfortunately, I didn't realise I had to give a talk, but anyway, today I'm going to quickly take you back up to warm, sunny North Queensland for a brief visit and talk to you about the DIPMA project. We think this is a very exciting project. It's almost a forgotten gem. I think there's a lot of really exciting work going on there. I'm just going to run you through that. Before I do, I just want to quickly acknowledge my team. We've got a fantastic, small but great little enthusiastic team full of energy, and it's a real privilege to work with these guys. I've got geologists including Julie Hugenholtz, David Webb, and Deanna Houston, who's here but wouldn't do the talk, so I'll hold that against her. We also have another director called Andrew Gilbert. He is a mining engineer, but in spite of his sins, I do forgive him. I think he always is prepared to get his hands dirty. He's currently up at site at the moment, and I think quietly he suspects he might be a bit of an amateur geologist, so I think he's a good guy. We also have Dave McGuinness in the room. He's a mate of mine. I've worked with him for over 30 years, and he does all things geophysical for us. And last but not least, our field crew. I mean, they've got some of the hardest work. We've got some pretty crazy terrain, and the amount of work these guys punch out is just amazing. So today I'm going to run you through some of the, what we're up to and where we're going, and hopefully, tell you a good little story. I flashed past the disclaimer in our cautionary statement. I mean, the underlying message here is I get very excited, so, take everything with a grain of salt, I guess. Just as a brief little summary about Ballymore, we listed literally 3 years ago, just 2 days ago in fact. We basically listed on the back of 4 projects here in North Queensland. We've got the Mount Malloy project, which is a high-grade copper VMS project up northwest of Cairns. The Radigore project up near Chillago, which is a base metal play. We've got the Ravenswood project down Charters Towers, a great little gold destination. And the one I'm going to talk about today, which is the DIPMA project, which is down inland from Proserpine. The DIPMA project, we actually are the largest tenement holder in this area. We currently hold 2 granted mining leases and almost 500 square kilometres of tenement. We also have a large mining lease application, which is well in process. This area, I think, is a forgotten gem. It's an area that gold was first discovered here in the late 1800s. And it was quite a significant gold mining area back in the 1890s and into the early 1900s. Interestingly, one of the last projects or mines found in the area was DIPMA itself in 1930, the DIPMA mine. And when it would operate between 1930 and 1951, it was the highest grade gold mine in Australia. It was averaged 151 grams gold, 66 grams silver, and 2.8% copper. We think this is a really exciting area. A lot of significant old mines in this area and remarkably little exploration, and that's where we see the opportunity. I'm going to talk a bit about data gaps today. We have numerous data gaps. I still can't get over how little work's been actually done in terms of modern exploration here. The geological mapping in this area is quite poor, and I mean, anyone who's walked out there for half an hour will probably realise why, because you're crazy to go walking around out there. It's very steep, thickly vegetated. But look, the more work we do, the more we find, the more we understand. There's also quite poor geophysics coverage. Once again, sadly, we probably have before we completed an airborne geophysics survey a couple of months ago, we probably had the worst magnetic and radiometrics coverage in Queensland. There's also limited geochemical analytical suites for what work has been done. Generally has very, very limited analytical suites of elements, so that's also a bit of a limitation. There's little to no drilling completed in this area, and last but not least, given the complexity of the intrusive terrain we have here, there's really quite limited geochronological information as well. Just to put it into a bit of perspective of where we are, just to prove that even in Queensland we can sometimes have some of the good stuff like the Tasmanides. In Queensland, basically we have Tasmanides extending up to the Torres Strait and they run all the way down to Tasmania. In Queensland we have 3 orogenic belts, the Neoproterozoic Ordovician-Thomson origin, the early Paleozoic Mossman origin up to the north there, and the Paleozoic to early Mesozoic New England origin, which is a sequence of marine continental sediments and volcanic rocks which runs out the east coast, and that happens to be where the DIPMA project sits. Moving a little bit closer into where we're operating, our tenement sits in here. It basically, once again, the area is dominated by Paleozoic and early Mesozoic rocks of the New England fault origin. but we also have Cretaceous intrusives and a later tertiary and quaternary cover in the area. The area sits in a structural zone which they refer to as Connor's Arch, which is basically just a broad anticlinal feature. The core of it basically is a set of Carboniferous and younger granitoids that sit in the core of it, and that's the pink area. And it's basically flanked on the western side by the Permo-Triassic Bowen Basin, and on the eastern side the equivalent in coastal sediments. Getting even closer into the project in terms of the geology, the area itself is dominated by this green rock type, which is what we call the Camilla beds. It's basically a Permo-Carboniferous set of volcanic, intercalated set of volcanics and sediments. It's subsequently been intruded by this orange unit down to the south, which is basically the Urano-igneous complex. It's a suite of granites. Both these rock types have subsequently been intruded by this red unit, which is the Hecate granite, which is an early Cretaceous intrusive. And it's very clear that where this is intruded into these, there's actually a lot of hornfelsing going on, and we see this aureole, and it's very clear in the magnetics. You can see this mag high that basically corresponds with it. Of particular note of this is the fact that the majority of our mine workings and old historic mines sit within that orogenic zone, in that hornfell aureole. If we look at the streamset geochemistry, as I've already mentioned, I mean, amazingly, despite the fact this is quite a significant historic gold mining area, remarkably little of our stream sediment sampling has been actually analysed for gold in this area. I still can't believe that either, but where it has been completed, it's fair to say that there's a significant gold anomaly sitting on to the west of us in the Normanby goldfield, and also up in the Ditmar area up in here. If we look at the copper generally tends to occur on what we see as these regional northwest structures, and we have some fairly significant copper anomalies sitting in there. The most obvious one is just off our ground called Julavon Creek. It's a historic porphyry deposit that was found by CRA in the 1970s. But it is interesting that Ditmar itself also represents quite a significant copper anomaly. Looking at the lead and zinc, you can see that basically the Camilla beds actually are quite elevated, and particularly around Ditmar itself. There's basically a 15-kilometre anomaly in zinc that's running over 200 ppm. We're at the moment in the process of undertaking further geochemistry sampling in this area to try and rectify the data gaps in our geochem, and we're doing 50-element switch, which is then also helping us. We're noting that a number of our deposits being lit up with other elements such as tellurium, bismuth, and other critical minerals or elements. So I'm now going to run you through the Ditmar project and talk a little bit more about it. One of the first things we did, look, this area, as I say, was one of the highest grade gold mines when it operated, 151 grams gold and 2.8% copper. The area just has had limited work, but it's quite a substantial, old set of workings. When we first picked up the ground, the adit had caved in, so we opened it up, but all it really we needed to do was scrape back the old adit portal. We've re-established the portal. Once we got inside, the ground was absolutely pristine, fantastic conditions, and that's really assisted us straight away because we were able to get in there, do mapping, channel sampling. We've got channel samples running up to 264 grams per tonne gold and 5% copper. But the most importantly for us, it also allowed us to get in there and set up drill platforms from underground. Given the steep terrain here, it's very difficult to find ideal drilling locations, and by putting drill rigs underground, it allowed us to significantly reduce the number of metres, time, money, so that was a fantastic result in itself. It also allowed us to drill in times of the year where most of our peers in North Queensland can't operate. We started drilling in January this year, and literally within a week of starting, Cyclone Kirrily came smashing along, and we didn't lose any time at all to weather. So it's once again an amazing result. When we picked up this ground, the most obvious question to ask is, if I'm mining 5 ounces to the tonne gold, why did I mine and stop less than 200 metres below surface? This was a question that we posed to many people. We heard lots of different answers. Some people suggested they hit very significant water at depth. Some people said that the load pinched out, and some people said the board of the original company went to jail. Our suspicion is that it's a combination of all three. But look, our initial drilling there did very quickly demonstrate that it did pinch out below level 7. But fortunately for us, that same drilling also showed us that there was a repetition sitting within 30 metres of the old mine. This has been an absolute game changer for us. And one thing I didn't mention, cannot believe the fact that this area has never had a drill hole into it before Ballymore came in here. At this stage, we've now completed 42 holes into it, primarily targeting that displace load. Sometimes we also hit the mine load behind it, but yeah, every single one of them's hit the gold mineralisation and hit the load pretty well where we expected. It's behaving very well. And we continue to demonstrate that we're getting similar tenor grades to what they had in the historic mine. Probably a highlight being hole 9, 4.3 metres at 29 grams gold, 11 grams silver and 0.8 copper, and within there's 2.25 metres at 55 grams gold, 21 grams silver and 1.5% copper. It's a really interesting area. The geochemistry of what we have seen so far is what we consider to be a classic IRGS system. We see that gold, silver, copper, bismuth, tellurium, arsenic, moly, tungsten, selenium. And the other exciting thing is the lode as we know it so far remains open in every direction. We just completed, as I mentioned earlier this year, the stage 4 program, and the hits just kept on coming. We kept on continuing to get really great results out of it. Probably the one of greatest note was 34. This was an interesting one because the lode appears to have actually split, and we got 2 intersections in it. One of 3 metres at 19.5 grams gold, and another of 3 at 17 grams gold. What you'll notice about all these intersections is, and this is something that's quite characteristic of this area, the old timers focus on that main little vein, which tends to be only 10 to 30 centimetres wide. But as you can see, there's generally, in all our samples, there's normally a high-grade core, which is running over 50 grams. But fortunately for us, it sits within a shear zone, which in the upper parts is only about 1 to 2 metres wide. As we're drilling deeper, we're finding it's getting wider, and we're now seeing it up to 5 metres wide. And within it, there tends to be a series of other little veins in there, and so that really allows us to bulk out a quite a significant zone. If we swing this around and look in the long section of the area, you can see the old historic mine workings of the red area in here. And as I've already said, there's about over 54,000 ounces produced out there. What I haven't said is to achieve that 151 grams per tonne, they actually hand sorted this ore. The main reason for that is they were actually taking the ore that they were producing from here either to Chillagoe or down to Port Kembla. It's over 1,000 kilometres, so it's fair to say their trucking costs were quite high. So they really want to maximise value. And they threw a lot of good material back into the backfill into the stopes. Where we've accessed the backfill in the stopes so far, we've collected quite a few samples now. The lowest result is 3 grams per tonne. The highest is 82 grams per tonne. It's fair to say there's clearly, back in the old days they called it waste. Nowadays we call it high grade. It's definitely another opportunity for us, and there is an old prospectus from 1951 that suggests that there's about 151,000 tonnes in this area that is averaging somewhere between 6 and 8 grams per tonne. We've basically completed now drilling on that displace load, effectively a similar area, about 200, 250 metres. And we think we've found a roughly similar amount of gold in there. So basically over a 200 metre strike length, we think there's potentially 100,000 ounces of gold there, which is quite impressive, but it's doing service to the grade we're seeing, and we think there's a real opportunity. It remains open in all directions, and we think it's a really exciting story. Not only have we been drilling, but we've also been doing some field work. I've mentioned to you already about the terrain. It's pretty steep through here, and it's an absolute credit to the team to have actually got out there to map and soil sample this area so far. 50-element analytical suite, fantastic, telling us lots of great, helping us with our story. You can see the area of our drilling so far is this little red zone here. What's interesting is the Duffer lode, which they mined in the Ditmar mine, we can see it extends for over 2 kilometres and remains open along strike. There's a whole series of other exciting structures and mineralised zones that we can see in here, most importantly probably being the Lockney lode. Lockney, historically, it was only shallow workings, but it averaged 540 grams per tonne when they were mining it in the early 1900s. We can see, there's basically hardly any work done on it, but it needs, it's clearly another exciting thing worth targeting. Where the Lockney and the Duffer lode come together, another interesting note is we're seeing significant copper mineralisation, over 100 ppm in this area, which we suspect may be indicative of leakage from a copper system sitting underneath it. So look, really exciting. We've rolled in a drill rig and we're doing the first step out surface drilling program. The surface program is very much a proof of concept. It's really just going out there to just drill a series of broad space holes to try and demonstrate that the structure exists. Once we do that, we'll go and break a few more eggs and we'll certainly get a lot more drilling going on, and there's potential for this to turn into a really large gold deposit very quickly. Stepping out even further in our tenement, this whole area has just got a whole range of different styles of mineralisation. I've already spoken about the high-grade mineralisation you see at the high-grade bonanza veins we see at Ditmar and Lamington. They also have similar veins here in Normanby Goldfield, but also down at Mount Hector and Cedar Ridge, we see a slight variation on that theme. We see more of a stockwork and sheeted veins set through there. Out beyond that, we also have breccia pipe systems just off our ground. Mount Flattop's a hydrothermal breccia. We also have one at Golden Treasure. And at Moon, there's basically a rhyolite flow dome with a breccia associated with it. I've already spoken about the porphyry systems. Julavon Creek just sits off our ground, and we also have Andromache sitting on ours. These are, once again, two porphyry systems found by CRO and MIM in the 1970s, and there's a number of others in the area. Finally, beyond that, we also have Mount Quandong. It's pretty well the tallest mountain in the area, and up to the top of that, there's a silica cap and some epithermal veining. So we've got the full suite here. It's really quite exciting, and we're spoiled for choice. One other thing we need to put a bit of geology on is also we see a whole series of little skarns, iron skarns, sitting around the margins of the Hecate granite as well. Here's a few examples of some of the mineralisation styles. There's some veining at Julavon Creek porphyry. There's some copper mineralisation from Andromache. There's some of the sheeted vein material, quartz pyrite veins that we see at Cedar Ridge, hydrothermal breccia at Golden Treasure, and the Duff Lode. It's fair to say Queensland, up in Queensland, we like our intrusive related gold systems. It's a prolific province up there. In northeast Queensland, we have over 40 million ounces of gold defined in intrusive related gold systems. We've got a number of big ones, whether it's Mount Lation, Kidston, Mount Ravenswood, and Pachingo. There's a whole series of them. It's a really exciting target, and we think there's potential for more of them. There's been some fantastic work done by guys like Greg Morrison and Craig Hart and a whole bunch of others, and that's helped us better understand over the last 20 years the styles of these things, the variations we can see, and also the geochemical zonations we can see. That's something we're using to apply for our exploration in this area. Ditmar, we think, is a type of intrusive related gold system, and we see a lot of the similarities to what you see in a lot of the other systems around North Queensland. We have a close spatial association with an obvious intrusive. We see mineralisation, it sits within that thermal aureole of the actual intrusive, and we see those classic geochemical zonations and associations that you expect to see in these systems. But there are some fairly significant differences between ours and most of the others we see in this part of the world. We've got a different age for our intrusive. The majority of these intrusive related gold systems in North Queensland are Permocarboniferous in age. This one is sitting associated with the Hecate granite, which is an early Cretaceous intrusive. It is interesting, the more work we're doing on this, the more we're starting to appreciate that there's a whole series of these later Cretaceous intrusives running up that east coast of Queensland, and we think there's some really interesting potential with them. The other thing that we're noting with these is there's actually a lot of the mineralising fluid associated seems to be more oxidised than we typically see in these. Most of these intrusive related systems in Queensland tend to be weakly reduced, but most of ours are oxidised. So look, it's interesting. In 1972, the Mines Department wrote a report in this area and noted what we were noting, that there is this association with the Hecate granite. But we are the first in this area to apply an intrusive related gold system or model for exploration. Here's just running through a few of the things we notice, the features we see in this part of the world. It's very common throughout our project area to often see our lodes sitting on the margins of lake dikes that have punched up into it, often Cretaceous dikes. Here's an example of dolerite dike against the volcanics, and there's a vein between it. This is out on the Cedar Ridge, where we've got a dolerite dike, and once again, we've got mineralisation associated with it. In terms of the alteration, we see it's basically a classic sort of just, almost idealised porphyry alteration model we see for the area. When we're drilling out here, we very regularly just see quite extensive propylitic alteration, chloride epidote carbonate. As we move in closer, one of the things we note around Ditmar, which is an interesting one, is as a halo to our mineralisation, we often see these carbonate lamentite veins forming on stockwork before we come into the main lode zone. And then around the lodes itself, we see that classic phyllic quartz, sericite clay hematite alteration. And then where our porphyries are, we then see the potassic alteration, the K-feldspar biotite alteration. It's just a classic system. Here's an example of the speculate hematite. This is one of the things that's a bit distinctive about this area. We quite commonly see speculate hematite associated with our mineralisation. And I think this really suggests that at least one phase of our mineralising fluids that we see in this area was strongly oxidised and within that hematite stability field. It's a little interesting quirk about the area. I've already mentioned about the zonation, and I won't harp on too much about it, but it's needless to say we do see a lot of similarities. We see that gold, silver, copper, bismuth, tellurium, arsenic, tungsten, selenium. We get some fantastic results through all, and we see some very clear zonation through here. We see the copper sitting on those northwest structures. You step away from them in places like Golden Treasure and Mixer, we see more of a lead-zinc association, and then places like Mount Quandong, we get that arsenic-antimony alteration, just stepping further away. We've actually built our own little model for the area, and I guess in summary, up at Dibma, we've got the Camilla beds preserved, and up in that high level, we tend to see mineralisation restricted to these high-grade little narrow veins. But it's interesting, down in our southern licence area where we've eroded that off and we're looking down the Urana igneous complex, we actually are seeing things that are more significant in the deepest parts of the system. We're seeing porphyry mineralisation and Andromache. We're seeing these network stockwork veins at Cedar Ridge. This is something we're using for our model, and we think there's a potential that underneath Dibma there could be something a lot more substantial as well. I'll very quickly run you through our other projects. I've already mentioned about the porphyry systems, how they tend to sit on these northwest structures, and there's some very clear geochemical anomalies. Here's our Andromache prospect. This was originally mined in the turn of the century, and they produced only about 600 ounces of gold. But it's interesting, MIM recognised it as a porphyry system in 1970, but they only analysed for copper and moly. A company called Mineral Resource Development came in 1979, entrenched it, and found some very significant gold associated with it, including up to 51 grams gold and 0.75% copper. They subsequently built a little plant, and they mined an open cut, pulling out the oxide out of this area from between 1979 and 86. Amazingly, no one, though, has really gone back and looked at the copper, and we think there's still great potential for the underlying copper system, and we're working on that as well. The Mount Hector goldfield was actually the first place where the gold was where gold was found in this area. Historically, it was quite a lot of workings in this area, and the main one being the Cedar Ridge area. This area basically is a large floodplain, and wherever ridges poke out, we see significant veining and lots of old historic workings. Interestingly, the Mineral Resource Development guys, when they were mining at Andromache, they went and took 6 50-tonne bulk samples from this and ran them through the plant. They obviously were looking to go there next. They reported between 1.5 and 4.8 grams per tonne, and with good recoveries. But amazingly, this place has never been drilled. We're looking to start drilling there in the next few weeks, so that should be quite exciting as well. We're trying to address all the data gaps we're facing in this part of the world. It's a blessing and a curse. We've got an exciting place that we think has a huge amount of potential, but has a distinct lack of data. So we're trying to address that. We're mapping as much as we are. We've collected over 5,000 soil samples already. We're doing stream sediment sampling. And we're also trying to address the geophysical data gaps as well. We're very fortunate earlier this year to be granted a CEI grant from the Queensland State Government for $300,000 to fly a detailed mag survey. We're still finalising that, and I'm waiting Dave McGuinness for some final products. But you can already see there's some really amazing, the amount of character and detail compared to what we had before is just going to be a game changer. It's going to help us focus in on targets, structure, alteration, and we can already see it's going to be an amazing data set for us. So in summary, the Dibma project hosts numerous historic bonanza gold grades, and this is one of the things that this area is sort of characterised by. But it's also interesting to note that there are some significant porphyry copper systems, as well as stockworks and massive sulphide, and a range of different deposit styles here. It's remarkably underexplored. I still cannot believe the lack of geological information, geochemical information, drilling, geophysics. And we think there's a really exciting opportunity here, a great opportunity for us. We suggest that this is actually a younger intrusive related gold system, a Cretaceous age one, and we think there's a really exciting opportunity, not just here, but elsewhere in Queensland if this does prove up. Look, there's already some really exciting results coming through, and we're really excited about the future. There's a lot of great work going on, so watch the space. Thank you very much.